So welcome everyone for the next session of the TUG 2022. I will be your host for the next 4 talks at least. And I want to dive straight into our next presentation by Mikhail Sundqvist. Mikhail is a senior lecturer in mathematics at Lund University. And he has been working on LaTeX and ConTeXt for more than 20 years. And as rumors goes, he's working with Hans Hagen on the luametatex, bit mysterious new tech engine, including re-implementation and generalization of mass typesetting. So welcome, Mikael, for your talk. Please, Mikael, take the stage.
Yep, thank you for the nice presentation, and also thank you for having the possibility to talk here. I will soon make the screen full screen so that we see what is going on. See. Can you see the full screen? Can somebody confirm?
Well, it's not really full screen. I see the menu on top, and the slides are not one slide. The next slide just peeks down from the bottom.
Okay, so then maybe I need to. What if I do it like this, something like this? I don't know. Let's see. Maybe it will work. Otherwise, I have to scroll.
I think that's fine.
Okay, good. So I will talk about some news about math typesetting in ConTeXt, and about the rumors, I can say yes. I'm collaborating on this with Hans Hagen, of course, since he is coding this. So I want to start by giving an example. So if we look at these two formulas, I wonder if we can spot any difference. Of course, the bottom one is in another color than the top one. If we look a bit closer at these two formulas, then maybe it's easier to spot some kind of difference here. So in fact, the space between the 0 and the equal sign is slightly larger in the black one than it is in the purple one. And the same goes for the space between the 0 and the plus sign. Yeah, so here I actually show them. In ConTeXt, we can show the space between math atoms, and we have an ordinary atom here and a relation atom and so on. And we see that between the 0 and this vertical line here, there is a small space. And that's the same between the 0 and the plus sign here, but not between the plus sign and not on the other side, so to say. So this is a bit uneven spacing, if you want. The guilty thing here is, as many of you know, the script space, which was introduced already in the beginning by Knut. He set it to 0.5 points, and I think that fitted well with his setup with 10 points, and then that has survived. Later formats also use that. So what should we do with this script space? If we say that I start here with very tiny details, I would say, but if we look at this, what should we do with it? If we want even spacing, the thing is that we cannot remove it completely. If we do that, as we have done here, then it's a bit difficult to see if the 0 belongs to the A or to the B. It's easier to see when we see it slightly larger here. So we cannot remove it completely, but we want to be able to remove it where it should be removed. And this is now possible because of many reasons, because Hans has opened up all kind of atom spaces and classes and so on. So we can actually set up to remove this script space if the next atom is a relation, for example, or if it's a binary operator, but we can keep it if the next one is an ordinary one, as here. So the green one is how it comes out right now then in ConTeXt. And this is more or less what we want. So I started out here with something that's very detailed, this is a small thing. I call this math micro typography. And I will continue with this, and then to give some examples where we see small details that I think we have improved. And then I will turn to macro typography. That's just what I've called it right now, which is a way of showing formulas or typesetting formulas, which I also think is new and innovative. And then in the end, if there is time, I will also give some comments and some something about further work or what we will do. Okay. So for this microtypography, luametatex is working with OpenType math fonts, really, and that's what we want to focus on. So we have these new atom classes that I will talk about soon, but we also have GUI files because these OpenType fonts, I wasn't there from the beginning, but as far as I have understood, there is not really a good standard, and different fonts behave differently. So we have some so-called GUI files that we tweak the math fonts to at least do as good as we can, so to say, with that. Another aim, a general aim, is to have consistent output, but also to have simplified input. I will give examples where that becomes clear as well. But for example, giving this explicit spaces, / comma, thin mu skip, or / exclamation mark is something that we would like the user not to have to do. Okay, so let's look at another example. So another example is fractions. So if we have typeset a fraction, let me call it traditional tech, which is something that then was before luametatex. Then we usually have gotten a small space around the fraction bar. So if we look at the next slide, we see that the space here is gone. There is also, oops, if we look close here, the space on this side of the equal sign is actually larger than the space on that side. I mean, it's really the details here in the beginning. So, so we have been able to remove this. And one of the reasons that we could do this is that we now have new atom classes. So we have a fraction atom here. This was set before with something that calls null delimiter space. So it was kind of a side bearing for fractions and fences. So if you did a fraction, you did you got this 1.2 points set to both sides. Almost always, I would say. Sometimes it was reset to 0 points, but you get it always. And if we look at this example, if you think of this gray box as the text block, so if we look at this example, we see that in the left margin, if it happens that the text starts with a fraction, we will get an additional space here. I don't know if you have noticed it or not. Now we don't. We don't get that additional space. Of course, we want some kind of space around the fractions, and this was in the winter perhaps that we at some point Hans realized that okay, we need to distinguish maybe fractions from other things and so on, and we need to open up to have new classes. So if we open everything up and add new classes like fractions, and we will see more of them later, then we can set up the space between these classes more granularly, if you want. So here we have the fraction. If it stands in the beginning of a formula, there is no space. Then we have a fraction binary space, of course, and then a relation fraction space, and we can look at this instead. And in the end, there is also a fraction ordinary space. So there's a space. So previously, this space between the fraction and the f in this case was taken care of by this null delimiter space. Now it's not. Now there is a space here. And I have written down here what's the spaces in this formula, which ones are present. Okay. But that's not the end of the story. Previously also we had in math more or less 3 different mu skips: thick mu skip, med mu skip, and thin mu skip. And even though if you could change the size of them, so to say, they were hard-coded in different locations in formulas. So if you change one of them because you want a bigger skip between two atoms, you will also change the spacing in other locations. That is not the case anymore. So we are free to set the skips between the atoms as we wish, and we are also free to introduce new mu skips, and we have done so. In fact, I think there are more than these if you look under the hood, but these 5 are the ones, so to say, the main ones that we use between atoms. So the new ones are tiny mu skip and petty mu skip. The old ones, the 3 ones, they are more or less the same, but as you see, we have altered the glue a bit for thick mu skip and also for med mu skip. In particular, we don't let it shrink to 0 anymore. Okay, so tiny mu skip and petty mu skip. Let's see why or where we are using them. So for example, the tiny mu skip, which is the bigger one of them, 2 mu minus mu, it's set between the radical class, I should point at the green one, the radical class, and the ordinary class. So there we have a tiny mu skip. It's also set between the fractions and the ordinaries, for example, but it's set in many more places, but this is one. So previously I think there was no space here. I'm not sure if there was a null delimited space or not, but now we have a small space after the fractions at least. The petty mu skip, which is the even smaller one, it's mainly used in subscripts and superscripts. So for example, between ordinaries and binaries, we now add slightly a small space here, and we think that we have these details now that we can add them, and I think it looks just slightly better. I mean, this of course this is personal. The good thing is that it can be set up differently if one wishes, of course. So we see there is also a space here between the ordinary and the binary in the exponential. Okay, so there are several new atom classes. There are engine classes, which is, I mean, in the luametatex engine, and then there are also ConTeXt classes. So we can add more classes, and it's not expensive to add them, so to say. So we can add them with quite a few members if you want, and of course, if you see this, you might get scared that you have to set up all the combinations of spaces between all these classes, but you should not worry about that, because usually when we add a new class, we set it to default as say, for example, the ordinary class, and then we just make a few changes where we think it's necessary. So there is no meaning that I start to discuss all these classes. So let me give examples instead. One of the things that was driving this in the beginning was that I was asking Hans about this backslash comma in integrals and this differential and so on. And so this was one of the first added classes, I would say, new classes, which is not a fraction class or something like that. So what we ended up with here is that we added a differential class. It was in the list, in the ConTeXt list, not in the engine list. And then we added a command, \dd, which is a differential d, simply. And if you look here, this is how it's traditionally typeset, this differential \, comma, and a dx, or there are different variants if you search for it, but this is a very common way of writing the differentials in the integrals. So what we do now is, well, when you typeset it, it's more or less the same. I mean, if you do \dd, you could define that as a macro, but it automatically gives the right spacing here. So a clo diff, a clo is a close atom, a diff is the differential, and this is the small space that it's inserted. But that's, yeah, well, okay, so I will first say that we can set it up to be upright. Some people like upright differential Ds, so that's just the general setup, and then all of them get upright. But what I wanted to say is that if you combined this \dd, the differential D, with other pieces in a formula, I think that we have set it up so that it looks right in all locations. Right. I mean, this is a matter of taste, of course, but it looks good in all places where I've seen it, at least. Okay. So another example, ConTeXt has had for a long time units and unit module and so on. And what we did here was merely to say that if we use a unit and we have something in front, then maybe the spacing between what's in front and the unit could be handled by this math spacing. So if we set it in mathematics, IM is inline mathematics, DM is displayed mathematics, then we get, well, the right I don't dare to say here because I don't work too much with units, but we get some kind of spacing in between, and it's of course possible to set it up if you want a different kind of spacing here. So we have set it up so that the unit will give what is called a dimension class, and then you can set up the spacing to the left and to the right of it. I will say something more about the left and right soon. Another example, just to convince you perhaps that this is a good idea, is the factorial class. So mathematicians usually want, for example, here in the denominator, a space between this factorial and the following ord, or if it's something else perhaps as well. And this is something we don't need to set manually now. The space is there because the factorial ordinary space is non-zero, it's positive thing. If we do double factorials, we don't get any space in between because there is no space between factorial and factorial, for example. So I think the factorials work as many people want them to work. So this is a very small class. The factorial class has one member, it's the exclamation mark. That's the only one, but it's a bit unique, so we set it up accordingly. So let me give an example where this is not really set up yet, but this is what I will do now is something that's suggested in this old typesetting book by Landsberg. It's over 400 pages of typesetting IDs and so on. It's back from the 60s or 70s and was used for typesetting Acta Mathematica, or as a rule for that. So there it's suggested that if you have the exponential e and you have a product with other terms, there should be a slightly space around the e. Okay, so we have the exponential class. We can, I just want to give this example also. This is more or less how our new class is defined. So so this is nothing that you should do in general documents. So you just introduce it by this one, and then you actually copy math spacing here. So it's by default the same spacing as the ordinaries. So if you do this, you can add some glyph or some symbol to the exponential class, and it will behave just like the ordinaries. But now if we want to set it up, again, this is also something that you should do once in some file, then we can use set math spacing. We set it between the ordinaries and the exponentials. We do it in all styles, and we set it to tiny. And we do the opposite, the exponential and the ordinary, all styles, and we set it to tiny. And it will look, a typical formula will look like this. So this is the top one is without this extra spacing. The bottom one is with the extra spacing. So we see that I have switched on the helper here. So we get an ordinary exponential space here. We get it here, there, and there. And what did we did set it to tiny muskip. One could think here that maybe the tiny muskip is okay here in the first case here, but not in the exponential. Maybe one wants a smaller one here, and that's also possible. So I used all math styles there, but there are different ones to choose between, all display styles, all text styles, all script styles, and so on. All split styles, that's display style and text style, all script style, which sets the spaces in the script, so to say. So say that we want to have it differently. So I don't show all the combinations here, I only show the exponential and the ordinary. If we do it in all split styles, that's display mode and text mode, essentially, then we can set it to tiny muskip. And if we do it in exponential, for script styles, we set it to petty muskip. And I don't show the helper here anymore, but now the space between the S and the E here, and after the exponential and the T, is slightly smaller. So we have complete control over the spacing, I would say. Okay. This is a silly example, but there is also a possibility to set different spacing, or to identify an atom differently to the left and to the right, so to say. So this fraction here is identified as a fraction to the left. We get a binary fraction space here, and it's identified as a relation to the right. So this is nothing that you usually do, but currently I think that the units are set up so that the units are identified as dimension to the left and as ordinary to the right. Not that it matters too much for them, I think, but it's possible to do this kind of different setup. We can also open up spacing in formulas. So that's one of the other big things. So we have a left and a right here, which was usually a sub-formula of itself. So if you added some spread, this is some formula from an old question on Stack Exchange, we could add the spread and we will see that it spreads. Okay, I will not say anything about that now, but maybe come back to consequences later. So that's what was it for the skips. And now for the fonts. So I use Bonum here, and if we don't do any changes, this is what we get. And there are several small quirks here. So the F is hitting the square bracket, the fractor Q is perhaps too small, or maybe it even looks bad, not fitting with the font. The prime is perhaps too high, the integral sign is too small, the 0 should be sitting closer to the integral, and so on. And with parentheses here, there is I will come back to that. And to solve this, or to fix these things, we use tweaks, or we set font parameters, either from the true fonts, or we introduce own font parameters to play with, which we then can set in these GUI files. So for example, in the GUI file, there is a dimension tweak, so we can fix problematic glyphs. So the F, it looks like this, it has a lot of italic correction, but it also sticks out to the left. So what we have done here is that we have offset the glyph, we have changed the width of the bounding box, and we have reduced the italic correction. So this, here we see the steps. And that has more or less fixed the F. For the primes, we have a tweak that we can position primes, and we can also do more things with combinations. If you do double prime and so on, and if you have primes in superscript, should it, we can see which version it will take and so on. So, so we have possibilities to tweak the primes as well. The integral signs, well, that's a font parameter. I don't know, in all the Geir fonts, it seems that this parameter is set a bit too small, at least for my taste. I think it's natural to expect the integral sign should cover more or less a fraction, or it should look a bit natural with a fraction at least. Talking about that, we can also make the integral signs grow. That we do with start integral, stop integral. So this is actually kind of a fence, but it has the subscript and superscript on the left part instead. And it can grow to what's included. This is maybe more for fun. You can actually have very large integral signs. Some people like that, some people don't. Okay, and then we have font parameters to play with to tweak the position of the limits as well. We can, yeah, if we look at this, the whole Factorial alphabet is perhaps too small, so we have a tweak where we can scale it up, the lowercase at least, and it will look fit better with the bonum. The same with the script. So the formula before and after the tweaks, they look like this. So I think at least that the green one is a clear improvement over the black one. And all these are done from the Goody file. The parentheses, let me not get stuck here, but the open type fonts, they have many different sizes, and it's not really clear which sizes you should get if you use the big, yeah, these ones. So we can set them to choose explicitly in the Goody file, so to say. So we see that when we set it, they grow a bit more, which I think is a good thing here. If you look carefully, the 2 here is sitting closer to the solidus than it does above as well, and that's another fix, which is a kern fix. So we can kern. We take the solidus, we kern it, the top left and the bottom right one. We just kern it a bit. We don't do it on the other corner, so it will not be pushed in any direction there. Another tweak is the accents. This is not bonum, it's Latin modern, so they are sitting a bit on different heights and so on, and yeah, so we try to make it uniform. Some of the glyphs are more off, as you can see. I think that what the Geyer people did when they did the fonts is that they put the anchor to have the glyphs above the highest point of the glyph. I mean, I think that's pretty visible here on the lambda. So, and here maybe we have 2 points that's highest, and then the glyph is there. So we can move the anchoring and set it up so that it looks better. Okay, that's it for the details. There are more things with the details, but let me turn to macro typography as well, because I don't have too much time. So let me, so maybe now, if the previous, what I just said is maybe a bit more involved, this is more maybe for the users, for everybody. So start formula, stop formula is the way to do displayed mathematics in ConTeXt. Start a line, stop a line is for all kind of alignments. And number equations we get with start place formula, stop place formula. And we will see a lot of examples. So we start with just a simple example here with just some formulas, some simple formulas that fit on a line, and nothing is going on here. We can have formulas that stick out in the margin, so to say. So this one, it sticks out here. Note, I added split equal to no here because I didn't want this to split. This is one of the major nice things, I think, that has happened. By default, the split key is set to text. I add it here explicitly just so that you can see it, but this is really the default. So displayed formulas, they are now broken over lines by default. And as you can see here, the breaking point is perhaps not optimal. So we can play with that. There are different split options. We have split equal to text, then it splits on one page, so to say. Split equal to page, then it's allowed to split over pages. Split equal to no was the first example where it didn't split at all. And this is, text and page are really the same, but they have different setups of penalties, so it's penalty driven. So I will, maybe that's a bit better. So we can put a line equal to flush left inside the previous formula, and we add a break here as well. So we break the formula where we want to break it and then align it left. This is just showing you this is not the right way to typeset this formula either. And then we can add, we can push the line, so to say, if we want. So we can push the first line with skip here, 1 EM, and the second one 5 EM, and then we get something that at least looks better. But that's not the way to do it here, to flush it left and then push it, but there are better ways to do it. The align can be middle aligned, all the lines are middle, flush left, flush right, or slanted. And let's look again at this one. So if we use a line to be slanted, it's more or less a left to right formula. So the first line is left aligned, the last one is right aligned, and the lines in between are centered. So that's multiline, more or less, in AMS. And we can add a margin. So I think this one looks now okay. We can define if we want to use this kind of formulas more than once or several times, or have a same setup, we can define our own type of formulas. So we define the multiline formula, which is slanted, and then we can start multiline formula instead, stop multiline formula. And here I added margin equal to 1 EM. I could have added that in the definition as well, but still set it to something else, of course. Yeah, so this is just another example of this start multiline formula, stop multiline formula, how it can look. Yet other examples. So if we don't, the default for a line is middle. So if we don't do anything, we can use a line here as well to align the formula. So if we put a line here, just to the left of the equal sign, we will have that as an alignment point. And then we use break here to break it. And we will see that the next line starts at the equal signs. So this is perhaps the moment to say that this is really a paragraph, so to say. So we have a long formula and it's broken at the points and typeset. So this is not 1, 2, 3, 4 different formulas in a grid or something, but it's a paragraph. Yeah, but it can be done with alignments as well. So as you see, the examples, they are exactly the same if we do it with a line. Yeah, so we can put a line. So maybe it's not clear exactly what we put the line here. We put it first, and then we have a skip in here, which is text distance, which is 8 EM in this case, and then we skip from there. So we have the text distance parameter, which is so to say the skip on the next formula. So it's maybe clear if we show this with a helper. So we align here. We have text distance, which is added to all the coming lines, and then we have skip here if we want. I don't say that we should have a skip here increasing gradually here. It's just that it's a bit for fun, and also we add 1, 2, and 3 here, so they come in some unit, which is 2 EM, I think. But that can be set up as well if you want. We can have slightly more advanced ones where we indent a bit and then we indent more, and that's just done with this skip thing. So we align, then we have a text distance which is smaller, maybe 2 EM here, and then we skip that line as well. So let's see, we align, we break, we skip 4, and then we break again. And observe one good thing here. This formula is broken. I mean, it's just broken into pieces, but it's still a paragraph. And this fence, the square bracket fence here, is broken over lines. That's not a problem. So that's also one thing. So they are unboxed somehow, and then they are put together again in the end with the right spacing and so on. I think that was something that Hans had to work a bit to get to work, but it works very well, and it's of course very nice. So we don't have to match the sizes of the fences anymore on different lines. We can change the size of the fences, on the other hand, if we want it. I mean, in this case, the parentheses on the right side here maybe are too big. So we can set them explicitly, size equal to BIGG. We can also, if we use left and right instead of the fenced mechanism, we can set \F3 that will force this to the third size, so to say, which is BIGG, get the same output. Some other smaller things. So we can define our own fences. This is more or less like this declare pair delimiter for the people who have used math tools. So a set, for example, we can inherit it from braces, which is already there. We say that the middle should be this 7C, which is the vertical bar, and we want it to have a command as well. Then we can do \set, and we can say fence where we want this one. And that's the bar here will become a middle class. And it's not the same middle class as in eTeX. This is a class on its own, so to say. It's not some opening class which is obscured somehow. Okay, we can use struts to control the heights in fractions, for example. So there are different types of struts, and we get some different types of spacing, vertical spacing inside fractions. I think this is, I think ConTeXt usually have a bit more struts than other packages. We can define our own fractions, and this is just to see that we can, you can define, I mean, for example, Christoffel symbols or Legendre symbols and such things via this setup. Alignments, they are of course there. Not so much to say about this. We can, there is one alignment environment, and we can use it to get what more or less what we want. So we can set the distance to 2em between the columns if we have multiple groups of alignments, so we can make it completely filled, so to say, or left to right adjusted. There are cases, not so much to say. We can have simple aligns, maybe that's more inline things, so it can look like this. We have a brace to the right. We can add text to formulas, so we add to break here. We can add a text end here. This is something that's from this Landsberg book as well. It doesn't prefer the short interline text, but rather that this one text is written on the same line as the next one. This can also be done with the lines. So text : 2 adds it on the second line. Formula numbering, well, then we have to add start place formula, stop place formula. For split formulas, the numbers appears on the right. We can set it up to so that they appear on the left instead. We can number alignments independently or with subformulas. I mean, with A and B's if we want, and this collected, this simple align that I just defined. If we want to number this, see this as one unit, we should probably add a brace here and have one single number there. But we can also, if we have several formulas, we can say start subformulas, stop subformulas, and we get this subformula numbering. The period here, if somebody wants, it's easy to remove it as well. Yeah. And matrices, we can have matrices as well. This is not really new. This is a bit new, this \HF. It's a good thing to have, instead of having this ampersands, to have these two-letter commands here. So we have NC for new column, but we have HF for a horizontal fill. That's also something that can be set up, of course. We have VL for vertical line, HL for horizontal line. We can do border matrices. Then there is TT, top text, and so on. And there is also RT for the right, LT for the left, and BT for the bottom if you want. We can define own matrix environments. So for example, determinant, then we can add a simple command to have a simplified input if you want. Then of course you cannot use all these two-letter commands, but if you only have numbers, it's pretty convenient. Okay, so that's more or less what I had time to say something about. What's left is documentation. I'm writing a manual more for the user. Hans is writing more technical parts. I think the manual is now about 100 pages, and since there has been an active implementation of new stuff, it has stalled a bit during the summer, actually. There is also fine-tuning of parameters to be done for more fonts, and we also need feedback from other users. Let me just mention, I see that the time is almost running up, but let me just mention some of the things that we are thinking about. For example, if we have different formulas, this is the quad here is adding the space between these ones, but that's a bit what we want to come away from. And also the commas here and the period, should they be math commas or a math period, or should they be text? So this is something we experiment with to have it as it's actually an own class at the moment with some spacing, and the commas and the period here are from the text font and not from the math font. There is also, we can add start formulas, and then we will have equal columns with all the formulas. I mean, that's also something to set up probably. This is new from yesterday. There is a user who wanted to have unary operations, and that's something that I don't know. I'm hesitant here myself, but for example, one could think of a unary minus. It could be useful. The names here are not really supported names. They are just for this document, so to say. Something to think about how to do this right. It's a pity that these signs, I mean, for example, the unary minus sign is not present in the Unicode math. Let me skip this one. It's something, and this is for decorating matrices. Let me just show that we can set up, this is not really new math, but we can set up theorems as enumerations. And this is the AMS style, more or less, I hope. If we look here, there is a break before this A. I could have prohibited it with a tilde. That's also something that we will look at. Penalties in formulas, and we have there are different ideas how to set it up so that you don't have to write these tildes and still get good line breaks. We can have titles as well. We can do a different setup if we want to have the Chicago style. We just add different keys to this enumeration, and with the same theorem we get something like that. Okay, so that was perhaps a bit too much of materials. I finally want to thank Hans Hagen, who is not really, I mean, he's not a mathematician and he's not doing math, but his enthusiasm for this is very appreciated from my side. And then my family, they have suffered this spring perhaps, but I also want to thank the nice people in the Stack Exchange chat for all the helps and comments and discussions. It has been very helpful as well. Okay, so I'm open for questions if there is time.
Yes, thanks a lot for the very interesting talk. Unfortunately, we have only very short time for maybe one or two short questions. Anyone here, you can ask in the QA and I will answer in the chat, or you can, I see one.
Yeah.
Yes. So Kave, please go ahead.
Hello, thank you very much, Mikael. I'm getting dizzy. So many good things in here, and I can see the history of ConTeXt behind it and all the. So very briefly, it's not a question. It's not a technical question. comment is that, from the day ConTeXt came out, I felt it should replace LaTeX because it was more elegant, more structured than LaTeX. But for some reason it didn't. And LaTeX is now 99.9% of tech users. So the question is, who is going to use this? It's a bit like a new word processor coming and saying, this is better than Microsoft Word. We know it's better than Microsoft Word, but no one's going to use it. What do you say?
Well, it's open for anyone to use. I mean,
I hope they use it, but it's just an uphill marketing struggle, if you like, because everyone uses LaTeX because everyone else uses LaTeX. You see?
Yes. Of course.
LaTeX is great, but I think ConTeXt is probably greater. Thank you.
Maybe different in different things, but I use it for a reason myself. I mean, I like it and I've used it.
I'd love to use it.
I used it to write my PhD thesis and the book as well. I mean, you can use it if you want.
I mean, little things like the fact that when you break an equation, you have to use a hack to have the same size delimiters. It's a thing we accept, but it shouldn't be, because you're keeping the meaning by having it as one.
Yes, exactly. That's following from one line to the other. So
exactly.
So
thank you. Good luck, and I'll keep in touch. Thank you.
Yeah, thank you.
Okay, thanks, Kave. Dian, a very short question, please. You raised your hand.
Sorry, Ulrike.
So no questions. Okay. So thanks a lot for the very interesting talk. I also had a lot of questions, but we are out of time. I'm sorry.
Yeah, I'm here if during the conference if there are more questions. You can just contact me. So that's no problem.
So thanks a lot.
Yeah, thank you.